All right, you guys. For the last couple days here in chemistry, we've been looking at where we get our energy from on Earth. And you guys have read about and seen that there are really a lot of different places that we get our energy from wood to wind, from the sun, from water, from coal, from fossil fuels. There's a lot of different places that we get our energy from. Today we're going to look a little bit more closely at a specific way that we get a hold of some of that energy, and that would be in these reactions called combustion reactions. So what is a combustion reaction? What does that word combustion mean? You've probably heard it before. Combustion means that we're going to burn something. Okay? And a combustion reaction, chemical reaction, involves some reactants here on the left side of the arrow and some products over on the right side of the arrow. So what do we need to start a combustion reaction? Well, we need some sort of fuel, and this fuel can be a couple of things. This can come in several different forms. We're going to take that fuel and we're going to combine it with oxygen. Okay? When we do that, a combustion reaction is going to start, which is what this arrow tells us. Now, the rest of the stuff to the right of the arrow, this is what is produced. So we're going to change that fuel and oxygen into new things in this chemical reaction. And there's three things that are produced in a combustion reaction. We're going to get some carbon dioxide released into the air. We're going to get some water vapor released into the air. And the most important thing that is produced in a combustion reaction is this right here that's marked in red, energy. This is the whole purpose that we run these combustion reactions. The reason why we're going to burn this fuel is to get this energy. All right, we're not so interested in the water or the carbon dioxide. Those are just kind of side products. But this energy is what we're going to harness and use to our advantage. So, just as a little example, think about a time when you have lit a candle, or if you had a fire outside. Okay, we have a fuel here. The wick of the candle is the fuel. When we combine that with oxygen and we can light that fire. Now we have a combustion reaction. Okay, what would happen if you cut the oxygen off in this reaction? So you seal a glass over a candle. What would happen to that candle? Okay, well, it would go out. The reason why is that if you don't have both of these, a fuel and oxygen, to start this reaction, then you're not going to have the reaction happen. So the minute that you cut that oxygen off, that flame, that combustion reaction is going to stop. So that probably is something you've seen before. So when we have combustion reactions, what are we burning? What is that fuel? Okay, the fuel piece really can be anything with carbon in it. We call the fuel carbon fuels. So what are some examples of carbon fuels? Well, wood is an example of carbon fuels. We used to use wood to heat our homes. So you burn the wood, you run a combustion reaction with the wood, it gives off thermal energy, which we would then run through the house to heat our homes. Coal is another example of a carbon fuel. We're still burning coal. We burn coal sometimes for thermal energy, and a lot of times in electrical plants we burn coal to get electricity, electrical energy. But the fuel there, the carbon fuel, is coal. Propane might be another fuel that you are familiar with. A lot of times in homes that are not in the city, you'll see propane tanks, and propane is in the gas form, and we can burn it to, a lot of times people will burn it to heat their homes, again, so you're taking advantage of the thermal energy. Another place that you'd see propane tanks is in grills. So they're usually not as big as the one in this picture, but you run some propane up through a gas grill, and if you can combine that with oxygen and light a flame to it, it will have a great combustion reaction to give you some good barbecuing. Butane is another example of a carbon fuel. Butane is going to give off a little bit more energy than propane, and a lot of times butane is found in lighters and torches. An octane, which is found in gasoline, is going to have more energy stored in it than either of these. And we burn octane in our cars. So you put that octane, which is found in gasoline, into the engine of your car, and in the engine it sparks it, which moves your pistons and gets your car moving. So we take advantage of the energy that that octane gives off when we burn it. So there are some benefits to combustion, obviously. This is why we do a lot of combustion, especially in the United States. One benefit is that in combustion reactions, you actually release a lot of energy. So in the fuel that you put in your car, you can put 15 gallons of fuel in there, and it's going to let you drive hundreds and hundreds of miles. And get that big heavy car to move hundreds and hundreds of miles takes a lot of energy. So there's actually quite a bit of energy stored in our carbon fuels. Another benefit is that we can use these combustion reactions when we want it. So a car is another good example for this. You put the fuel in your car, it's not just going to burn without you wanting it to burn. That fuel will sit in your car tank until you turn the key, and the igniter will then start burning the fuel for you. So it's really nice that we can use it when we want it. You can turn the heat on in your house when it's cold, but when it's summertime, you don't have to run that heat or run that combustion reaction. It's stored for you nicely. You can have propane sitting in a propane tank and only burn it when you need it. That's really helpful because that means we're not wasting those carbon fuels. The other advantage to combustion reaction is that carbon fuels are readily available to us. So some of them from within our country and the other ones that we import from other countries. But petroleum and coal and natural gas, they're all being able to be pulled from the ground on Earth, and especially in the United States, it's very easy for us to get a hold of these goods so that we can run our combustion reaction. So because they're available, it's easy and we use them. Now, there are some drawbacks of combustion reactions as well. Okay, I'll remind you there's the combustion reaction. So you have fuel and oxygen combined to start your reaction, and then you're going to produce carbon dioxide, water, and energy. Well, actually, one of those products, that carbon dioxide, that's not really a good thing for us to be releasing into our air. So a drawback of combustion is that it produces that carbon dioxide. And as we learned in our last unit, the more carbon dioxide that builds up in our atmosphere, the more energy gets trapped in our atmosphere, the warmer Earth becomes, and then it starts to create a lot of problems for us. Another drawback of combustion is that fossil fuels or carbon fuels take thousands of years to produce. All right, so in order for oil or petroleum to form, you have to have, first of all, things die, like trees or animals, and then they have to get buried and get buried deeper and deeper and deeper until they're so deep that all that pressure and heat starts to transform the carbon from the living things into carbon fuels. And in order for that to happen, it takes thousands of years. Well, that wouldn't be such a big deal except for that fuel that takes thousands of years to produce, you can burn in a matter of seconds or minutes. So we're using up our fossil fuels much faster than they can be replenished on Earth. And as we use them up, they become more and more expensive. So that's another drawback. We see this with gasoline. The more scarce gasoline becomes, the higher the prices are. Just a couple years ago, it was $4 or $5 a gallon. And when I was young, you could get gasoline for, at one point, 89 cents a gallon. So we're using gasoline very quickly. And as it becomes more scarce, as we use it up more and more, it becomes more valuable. And people will pay more for it, and therefore prices go up. This is true of propane and other fuels as well, but the one we see most often is gasoline. So there is some drawbacks there, especially, you know, if you're living in a country that doesn't produce a lot of its own oil, like the United States, but we use a lot of oil, in the United States, then that kind of makes you dependent on other countries for this resource, which makes the prices go up even more. So there you have it. That's the gist on the carbon fuels. Now, in order to kind of look at these carbon fuels a little closer, you're going to do an activity called Who Has the Oil? And there's 2 sheets that go along with this. Those 2 sheets are found in the box in the back of the room. You should grab them and put them in your notebook. And for the first time this year, you're going to need your ChemCom textbook. You probably didn't even know they existed. But they are found in the cupboard right above the sink with the volleyball poster on it. So if you're not sure where that is, just ask Miss Bankston and she will point you in the right direction. If you have any questions, let me know.